So we know that every factorial from 5 onwards ends in a 0, right? 5 factorial is what? 120, and every factorial after 5 or greater than 5 is always going to end in zeros. So can we find how many zeros will be there at the end of a factorial? For example, if we take 13 factorial, can we say that 13 factorial is going to end in n number of zeros? Let's see how we can find this. So again, as we always do, let's start off from the fundamentals. Let's look at 5 factorial. What is 5 factorial? 5 into 4 into 3 into 2 into 1. And when we multiply this, we get 120. We know 5 factorial is 120, or 5 factorial ends in 1 0. Now how do we get this 0? Now in a product, whenever we multiply, let's say we have n1, n2, or some quantities, whenever we multiply this by 10, this is going to end in a 0, right? How did we get this 10 here? How did we get this 10 here? We get 10 for every pair of 5 and 2. So 5 into 2 gives you a 10, and the rest of the products when multiplied by this 10 will always end in 1 0. So if we have 2 pairs of 5 into 2, if we have 2 pairs of 5 and 2, then this will be nothing but 10 into 10, so we will get 100. So the product will end in 2 zeros. So we can say, if in a product, if we have a pair of 5 and 2, that product is going to end with 1 0. So the number of zeros at the end of the product or the factorial is nothing but a product, will depend on the number of pairs of 5 and 2 that is there in that factorial or product. So let's work with another small number and then understand this concept better. So what's 12 factorial? 12 into 10 into 9 into 8 into 7 into 6 into 5, 4, 3, 2, 1. Now, how many zeros will 12 factorial end with? It is multiplied by 10, okay, and this 5 into this 2 will give us one more 10. Now this 10 is nothing but 5 into 2. So how many pairs of 5 and 2 do we have in 12 factorial? This is one pair and this is the other pair. So we have 2 pairs of 5, 2. So 12 factorial will end in 2 zeros. We'll have some numbers here and then 2 zeros at the end. So if we are looking to find the number of zeros that a factorial or a product, it need not necessarily be a factorial, will end in, we just need to find the number of pairs of 5 and 2 that is there in the product. So that's the logic, or that's the concept behind finding the number of zeros at the end of a factorial or a product.